To prove something by deduction, we must use mathematical rules that we assume to be correct to form and manipulate statements to demonstrate the truth of the thing that we are trying to prove. The new example I am going to show is how to differentiate polynomials from first principles. Other relevant proofs by deduction I have done are those for arithmetic and geometric series, which you can see in the sequences and series videos. Consider a general term in a polynomial. We can focus on just one term since each term in a function gets differentiated separately. As x changes, y changes, and dy dx at a given point tells us the ratio between a tiny change in x and a tiny change in y at that point. To figure out what that is, we ask, what is the difference in y between 2 points separated by a distance delta x? This will be the y value at x, and this will be the y value at x plus delta x. And so the change in y, delta y, is given by the difference. The ratio between delta y and delta x is found by dividing by delta x. Now, we want the value of this ratio at the original point. So we are going to bring this second point closer and closer to the first until it is as close as it can possibly be at a distance dx. Now this bracket term can be expanded out for all powers of n using the binomial expansion. This means the first term cancels with the negative here, and since we only have delta x terms remaining, we can cancel with the denominator. As we bring delta x closer and closer to 0, these terms with a delta x become less and less significant compared to this first term without one, until they disappear in the infinitesimal limit. This leaves us with the result that the infinitesimal limit of delta y over delta x dy dx for a general polynomial term of this form